January 1992. In Sumatra's equatorial jungle, inhabited by monkeys, snakes, and even a few tigers, a team of surveyors is preparing a major project, Singkarak. Dumez, in a joint venture with Italian and Indonesian partners, was awarded the contract to build this large-scale hydroelectric project, which is unusual as it does not have a dam. Water from the 1,100 square kilometers of Lake Singkarak is channeled through a 16-kilometer long tunnel extending from the lake to the underground powerhouse at the bottom of the mountain after a 300-meter waterfall. Lake Singkarak lies in a large tectonic depression surrounded by volcanoes, some of which are still active. One of them, the Merapi, erupted several times during the construction of the project. At its foot, fertile paddy fields are harvested 3 times a year. The Minangkabau live here, in housing that is very typical. Before the construction of this project, all the water from the lake flowed into the Ombelin River. A diversion weir was built on the lake to control its water level. A minimum discharge is allowed into the river for irrigation and domestic use. On the other side of the lake, the main intake feeds the water into the tunnel. It was built by open excavation, then lined with a wall of secant concrete piles, strutted by large steel pipes at various levels. Afterwards, peace descended on the site again, and it's hard to believe that 8 cubic meters of water per second are now rushing into the tunnel. The excavation of the tunnel was carried out from several points. The upstream part was excavated by drilling with wheel-mounted jumbos, blasting with dynamite and mucking by wheeled loaders and trucks. This is a classic sequence of operations. However, due to the poor ground, the round length often had to be reduced from 3.5 to 2 meters or less, and the vault and walls had to be supported with numerous anchors and thick shotcrete projection. Halfway downstream, a road was built and a platform erected to enable construction of an intermediate access gallery and thus start the longest stretch of tunnel. It was excavated by a Robbins hard rock tunnel boring machine. This machine has a 6-meter diameter head, fitted with 40 cutters. It rotates against the rock, removing chunks of granite at each turn. Large water inflows considerably hindered progress. The material was conveyed into 20-ton muck cars, forming a train, which was driven through the already excavated tunnel and outside onto the platform. Here the muck cars were emptied in one go on a rotodump. The big event of the excavation was the breakthrough between the upstream and the downstream heads in March 1997. After difficult excavation work of 12 kilometers of tunnels lasting over 4 years, the two teams met, one coming from the north by drill and blast excavation, the other from the south with the tunnel boring machine. The 4-kilometer-long downstream part of the tunnel was excavated from two heads by drilling and blasting techniques using jumbos on rails. A continuous digging arm loader loaded the muck onto trains. The junction between the two heads took place in the middle of the stretch. A temporary bridge was built here to cross the valley with the equipment. Then steel pipe sections were installed on the bridge and welded together. Then the bridge was dismantled. Along the Anai River, a 100-ton per hour crushing and screening plant was installed to process the aggregates for the concrete using material from the river. The concrete was mixed outside in two 40 cubic meter per hour batching plants. It was transported in rail-mounted mixers or in truck mixers, then poured behind metallic forms. About 500,000 cubic meters of concrete were used for the various structures in this project. A small dam was also built on the Bulu River, 500 meters away from the tunnel alignment. After being desilted in a wide cavern, its waters flow into the main gallery, adding more discharge and waterhead. 300 meters above and upstream of the powerhouse, a large upper chamber connected to a lower chamber through a 100-meter high shaft was built to absorb the surge which occurs when the spherical gates upstream of the turbines are closed. A waterproofing membrane was placed between the shotcreted ground and the concrete lining. Gates were installed at the top of the pressure shaft before the drop down to the powerhouse. The pressure shaft was lined with 4 centimeter thick steel pipes encased in concrete. The powerhouse is a 25-meter wide, 90-meter long and 35-meter deep cavern, excavated underground into the granite. It was excavated from the top down and took 1 year to complete. Then another 2 years were necessary to place the concrete at various levels and to install the equipment. It houses 4 turbines driving alternators with a total power of 175 megawatts. To finish off, the machine hall was decorated like a mosque with marble flooring and a curved suspended ceiling. A 1-kilometer-long tunnel provides access to this powerhouse. Its construction was long and difficult because it crosses several weak zones. However, once lined, it looked just like an ordinary road tunnel. Construction of this challenging project lasted from 1992 to 1998 in very difficult conditions. It involved building 24 kilometers of tunnels, shafts and caverns. 800,000 cubic meters of underground excavation carried out using several different techniques. 400,000 cubic meters of open-air excavation, close to 500,000 cubic meters of concrete, and 20 kilometers of roads. Over 100 expatriates and 2,000 staff and Indonesian workers dedicated a good part of their professional life to Singkarak, and they can be proud of the achievement. On completion, PLN can considerably develop the electrification of this province of Sumatra, promoting industrialization and bringing the comfort of electricity to remote villages.